All right, geometry students, we're on to section 6.3, which is now talking about testing for parallelograms. Okay, so we talked about all the properties of parallelograms, and now we're going to talk kind of like the converse, like we kind of dealt with in chapter 3 with 3.2 and 3.5. Now we're going to work backwards and say, let's say you're just given a random quadrilateral. How can you prove that it is a parallelogram? So that's our objective. We're going to recognize all the conditions for and prove that a quadrilateral is a parallelogram. Okay? So the first one, we've got all this table with a bunch of stuff. It's kind of going to be similar to what we did yesterday. Both pairs of opposite sides are parallel. And again, it says both, so I'm just kind of looking at that saying, recognize that both pairs of opposite sides are parallel. Okay? And so that in our diagram up here with parallelogram ABCD, we would have to have both AB parallel to DC and you'd have to have AD parallel to BC. Okay? Again, I'm just going to make sure we understand it's and. You have to have both pairs of opposite sides parallel. And how can we tell that? That's going to be one I'm just going to kind of write it in here that we can tell by finding the slope. If they have, remember, if they have the same slope, then they're parallel. So we might have to do some problems with slopes. We might have to figure out their slopes. The next one, both pairs of opposite sides are congruent. So again, looking at the diagram above with parallelogram ABCD, we would say that both sides, opposite sides being congruent, we'd have to have AB congruent to DC, and we'd have to have AD congruent to BC. Okay, so they have to be congruent and parallel. Again, I can't stress it enough, it's and, both pairs. So we've got the and symbol. Both of them would have to be congruent. Well, how would we know if they're congruent? So this one would be where we'd have to use the distance formula. Okay? The next condition to be a parallelogram is that both pairs of opposite angles are congruent. Both pairs of opposite angles have to be congruent. So in our diagram above, we'd have to be able to prove that angle A is congruent to angle C, and we'd have to be able to prove that angle B is congruent with angle D. Okay? Again, both pairs of opposite sides. So there's an and symbol there. Both pairs would have to be congruent angles. The next condition, the diagonals bisect each other. Okay? So we'd have to be able to prove that each little piece of the diagonals would be congruent to one another. So we'd have to be able to prove in our diagram that AE, little segment AE, is congruent to EC, and we'd have to prove that DE is congruent with EB. And how would we know? Again, both segments would have to be, they would bisect each other, so we need both of them. But how would we know that? We would know that by checking for the midpoint. They intersect, so they should have the same midpoint. Okay, next. The last one, too, is that if one pair of opposite sides is congruent and parallel. So you just need to be able to prove that one pair of opposite sides is both congruent and parallel. So if you can do that, then it would be a parallelogram. So if we could say that AB in your diagram above is congruent to DC, and you could say that AB is parallel to DC, then you would be able to prove that it's a parallelogram. And you could use the other side too, right? It's or And you could use the other side. You could use AD and BC. You could prove that they're both congruent and parallel, then it would be a parallelogram. So if you have all these figures down at the bottom, then the figure is a parallelogram. And in this case, if all these things are true, then the ABCD would be a parallelogram. Okay? So let's do some problems based on those. This is determine whether each figure is a parallelogram. And explain. What does it mean to explain? Explain is going to be, you're going to tell me a rule from the table. From the table that we just did. Okay? This table right here. So all this stuff. You give me a rule to explain why or why not it would be a parallelogram. So if we look at this first one here, we can see that letter A, that 12 is equal to 12. We can also see that 5 is equal to 5 over here. So we see that opposite sides are congruent. So I would say yes, that's enough because it says both. We have both sides are both pairs of sides. Opposite sides are congruent. Okay, both pairs are congruent. Looking at B, well, we can see right now that we have opposite angles congruent, and we have an opposite side congruent, but because we don't know what the other angles are, and we don't know what the other sides are, we still don't have enough information. So it's not enough information for us to prove this one. If they gave us a little bit more. And again, it's got to be a rule from the table. So if you can't satisfy any of those conditions from the table, then it would not be, you can't prove it to be a parallelogram. Okay? The next one, find x and y, so that Fgh J is a parallelogram. So, looking at this problem here, x and y, if I look at x, if x is a if this is a parallelogram, then this side would have to be congruent to this side if it's a parallelogram. So I could set those two equal to each other and say, well, 6x plus 3 equals 15, and then I'm going to subtract 3 from each side. So 6x would equal 12, divide by 6, and x would equal 2. Okay? For y, I could kind of look at the same thing. If it's a parallelogram, then this has to be equal to this, right? These two sides would have to be equal. Well, if that's the case, then I'm going to have to say, well, 4x minus 2, excuse me, 4x minus 2y equals 2. Well, this is a little trickier one, right? Because now we're in a situation where we have two variables. But luckily, we found out that x is equal to 2, so I can take that 2, and I can sub it in here. So now when we do this, it's going to be 4 times 2. So 8 minus 2y equals 2. And from there, I subtract 8 from each side, so that negative 2y equals negative 6, and y would be equal to a positive 3. So my final answer here would be x equals 2, y equals 3. Okay? Next one, involving the diagonals here. We've got fk is 3x minus 1. They give us all the information in the diagonals. So fk is equal to 3x minus 1. Remember, this has to be equal to this for it to be a parallelogram. And this side here has to be equal to this side here. So let's just write in the given information. They give us that fk is equal to 3x minus 1. And that k, kg is 4y plus 3. So that's up here. 4y plus 3. And they give us that kh is, or jk right here is 6y minus 2, so that's this one. And that kh is 2x plus 3. Okay? So remember, again, talking that the diagonals would have to be congruent, I could set these equal to each other to figure it out. So for x, I would just go 3x minus 1 equals 2x plus 3, and you could solve from there. You could do the same thing with your y's and say 6y minus 2 equals 4y plus 3, because they would have to be congruent if it's a parallelogram. Okay? Let's continue on here now. Let's go to, we'll probably be able to speed through a couple of these. Again, finding x and y. So in this case, we would look and say x, it's right here. We'd have to have the angles be congruent, so I could set those up like that. And again, y, I could do the same thing. These two angles would have to be congruent as well. So I could say 4y plus 4 is congruent with 5y minus 26, and I could start solve from there. I'll let you guys get started on there. Same thing on number 5. We could use opposite sides, right? They'd have to be congruent, so set those equal to each other. These two would have to be congruent, so we have to set those two equal to each other, right? We can work on those. All right, number 6. Determine whether the quadrilateral is a parallelogram. Okay, so again, we have to decide how we're going to do this. Determine whether this quadrilateral is a parallelogram. In order to do that, we've got to show that both pairs of opposite sides are parallel. Okay, and that's what it tells us to do. Show that both pairs of opposite sides are parallel. So it gives us the coordinate points here. So let's kind of just roll up a graph here real quick. So A is at 3, 3. B is at 8, 2. And then C is at 6, negative 1. And D is at 1, 0. So we've got our parallelogram here, just kind of sketched out, A, B, C, D. Okay? And really, we're kind of looking to see, is it a parallelogram? So really, if we're going to try to justify that they're parallel, how do we figure that out? We're going to have to use the slope to determine that's a parallelogram. Right? And remember, we want to have opposite sides be parallel, so we're going to have to look at the opposite sides. So that's kind of what we're looking at, is do the opposite sides have the same slope? So in this case, remember, slope is rise over run. Okay? And you could use that way, or you could use the formula, y2 minus y1 over x2 minus x1. So it's kind of your choice on which way to use it. You have the graph, and you can go rise over run, or you could do the slope formula. So I'm going to kind of do both ways here. So let's look at the slope of AD, and then we want to look and compare that to the slope of BC, okay, and see if they're the same slope. That's the big question mark, okay, between these two. So AD, I'm going to go rise over run for this one. And I'm going to say, okay, rise, I'm going to go 1, 2, 3 over 2. So my rise is 3, and my run is 2. So 3 halves would be my slope. For BC, let's see my rise over run here as well. 1, 2, 3 over 2. So I have the same slope. I have the same slope, opposite sides. Okay. I also have to make sure both pairs of opposite sides. So I do have to do the slope of AB, and I have to do the slope of DC, and I have to make sure that those are the same. If they're the same, then I know that it would be a parallelogram. So if I look, and I can do slope formula, or I can do rise over run. For me, it's going to be quicker to go rise over run, but I could also do the slope formula. So let's do the slope formula for that one. For AB. So if I went 2 minus 3, it would be negative 1. And then 8 minus 3 would be 5, so it would be negative 1/5. For DC, if I went 0 minus a negative 1, I'm going to get a positive 1. And then 1 minus 6 is going to be a negative 5. So either way, right, it's still going to be negative 1/5. So they are the same. So because the opposite sides have the same slope, then this would be a giant yes, it is a parallelogram. Okay? All right. This one, it's going to give you the coordinates, kind of ask you the same thing. So try this one on your own. And then that is it. We'll take your questions when you come in the next time I see you. Okay? That's it. We'll see you next time.